Okay, welcome to the Diffusion Lab tutorial. I'm going to go over the Diffusion Lab, how you should teach it, instructor tips, how to do it by inquiry, alright? So, let's just start. I've got the student packet in front of me, and we'll start with the very first activity. Actually, let me back up. What I think is best is if you actually have students start with activity 5, the potato wedges. The potato wedges take about an hour to incubate, and so you want to have them get started on that right away. And so to do the potato wedges, I actually don't have a potato with me, but you're just going to get, there'll be a cutting board sitting out and a knife. So lab tech, make sure you've got a cutting board, a knife, and a potato. And you're just going to cut the potato into French fry size strips, but nice thin fries, because you're going to have to put them into these tiny little test tubes. So make sure that the students cut them small enough. When you're done with the potato, if you wouldn't mind throwing it back in the refrigerator, that'll save it for the rest of the labs. Because each lab group only needs 2 little tiny strips of potato. And so they're going to cut their tiny little strips of potato, and they're going to take 2 test tubes, and they're going to label them potato in salt water, potato in fresh water. And then they're going to put the potato strip in and then cover the potato either with distilled water. It actually doesn't have to be distilled. It's out of the tap, whatever is fine. And then the other one they're going to cover in the 10% sodium chloride solution, 10% salt, which the lab tech you should have this at the table in their little bin, so they should have a 10% salt solution. So you're just going to fill those 2 and then set them aside. So just have students do that very first before they get into the lab. Just say, hey, just do this really fast because it has to incubate for an hour. Okay, so let's start back at activity number 1. So today, the whole point of today is to teach them about membrane transport, but we're going to start with simple principles of diffusion, and then we'll work our way up into membrane transport using both red blood cells and Allodia plant cells, and then also using the potato and using an artificial membrane in the dialysis tubing. But in class, we're going to go over, why is it important that tonicity is the same if we're in an isotonic situation, or what's wrong with being in a hypertonic or a hypotonic situation. And so that's what you're focusing on right now, and then we'll teach you about specialized transport across the cells and massive exocytosis and endocytosis. But we want to get down the principles of diffusion first. So in the first activity, they're measuring the speed of diffusion through different consistencies of matter. And so each lab group should have a petri dish, and it should be full of agar. Now, I didn't do the agar today because I don't want to waste it. It'll start to go bad, and so we'll make the agar right before the lab. But in the bottom should be agar, and in the top it should just be a lid. They're going to use both. So in the semi-solid, they're going to take their agar plate, and they're going to we're going to use potassium permanganate crystals. So that's this stuff in the silver container, KMNO4. And it's in the silver container because it breaks down with light. And so you just want to make sure you don't leave it out for a long period of time, like leave the lid off for a long period of time. But they're going to take a simple crystal and place it down onto the middle of their petri dish, and they're going to use a plastic ruler. So every lab should have, or every lab group should have a plastic ruler, and they're going to measure after, 20 minutes, how much the purple has diffused out on the agar, okay? And they just need one simple crystal. And I'll actually bring the camera over here and show you how to do it when I do it in the water, because they're going to do the same thing with the water. So that's a semi-solid. They just place it in there and they wait 20 minutes and they measure the radius, how much it's gone out, in millimeters, okay? And then they're going to convert it to millimeters per hour. So if they only measure for 20 minutes, then you can just times 3 to do how many millimeters an hour. In the liquid, so what they're going to do is they're going to take their lid and they're going to fill it with water, and then they're going to place a crystal right in the middle, but they're going to place it on the table somewhere where it's not going to get bumped. I recommend they go to one of these side tables so that nobody bumps it while they're moving around with their chairs. You lay the petri dish on top of the ruler. I guess you should have the millimeter side up. On top of the ruler, and then they place it in there and they wait 10 minutes. That's why you want it sort of out of the way, because it's going to sit there for 10 minutes and they're going to see how far it diffused in 10 minutes. So I'm going to show you that right now.